Okay, so now let's say we have our data here. We have the averages, we have the error values, and we want to go ahead and graph it. And because these are discrete individual treatments, it's going to be a bar graph. Now, rather than selecting my data like this, that'll give me all of the data plus my average, my errors, and that's not the appropriate way to graph it. So what I find the easiest thing to do is to take your different groups that you have. I'll plot those over here. And then what I'm going to do is I'm going to copy my data and again paste it over here. But when I do this, when I paste, I have to paste special. Because if I paste it just generally, what's going to happen is it'll paste the formulas and then I'll get an error because it'll have the wrong cells calculating it. So when I paste it, I'm going to paste special and just paste the values. So now I have all of those different values for the different treatments. And I'm going to just change this so that it's similar to the other, same number of significant figures. And then the other thing I'm going to calculate or copy over is my standard error, because that's what I'm going to use when I make my error bars. And again, I'm going to paste special. Okay. So now I have all of the data where I need it, and I can just go through and highlight those 6 cells because it's got the average for each of my 3 different treatments. And then to graph, I'm going to go to Insert. And again, we said this should be a bar graph, so I'm going to insert a 2D column. The only time you're ever going to use a 3D column is if you have 3 dimensions. That would be an X, a Y, and a Z. That's probably not something you're going to be doing anytime soon, so always use a 2D bar graph, not a 3D. I know that some people like to think that it makes it look fancy, but it's inappropriate for the type of data that you have. And again, we want column, not a bar, because a bar would actually give you a sideways graph. And we don't really do that in science because then you have your X and your Y or your dependent and independent variables on the wrong axes. Okay, so I'm going to insert my bar graph here. You can see I've got all of my labels already on the X-axis. For our graphs, we don't have a title in it because that is what a figure caption is for. So I'm going to eliminate the title. And then over here, I am going to insert my axis label, so my vertical axis. And again, remember this is plant height. And I'm going to put my units in parentheses, so we'll say centimeters. Okay. So now I have my nice bar graph that shows the average for the control of fertilizer A and fertilizer B. But I want to also include the error bars because this is just telling me on average how tall were the plants in each of those groupings. Again, it doesn't say anything about the variability. So to insert my error bars, I'm going to click on my data and go to Add Chart Element. If you have a newer version of Excel, oftentimes you get the little plus sign over here and you get the same options if you click on it there. Okay, so I'm going to Add Chart Element. I'm going to go to Error Bars. Now notice when I go over here, it already has standard error. You do not want to use that one. Those are generic standard errors, and it gives the same standard error value for all of your different data points, which obviously you can see for our 3 different treatments, we do not have the same error, so that would be inappropriate. So we need to go down to the More Error Bar options. And then I get this little window popping up, and I can do a custom one. So I'm going to click on Custom. Notice it already put in the error bars. Those are the standards. See what I mean? How they're all exactly the same height, which is inappropriate. So I'm going to specify my value. And when I specify my value, it gives me the option of putting in my own data. And since I calculated it, that's what I want to do. So I'm going to remove what's already in there. And notice this is a positive and a negative. The error that you calculated is the error both positive and negative around the mean for your different treatments. So I'm going to select these 3 and again do the same thing down here. And then I can say OK. So now you can see, let me make this a little bit larger, my graph here. And you can see that my control really is much smaller. So if I wanted to say, is there a difference between these? What I would have to be looking for, again, is that there is no overlap between the height of the bar or of the error bars. So if I were to draw a line from the height of this error bar and go all the way across, notice I don't intersect either one of those 2 error bars or the top of the mean for those. So I can fairly certainly say that the control plants are shorter than either of the fertilizer. Now notice that over here I have very different amounts of variability, much greater variability with fertilizer A than I did with fertilizer B. Now if I wanted to go across, again, it'd be very close to see whether or not those two error bars are overlapping. Okay, so likely there is not a difference between fertilizer A and B, but both of them have greater height than the control. Okay, so that's a simple bar graph with inserting your own standard error bars.